You know, in system design, there's this one skill that really separates the pros from the rookies. It's that first crucial step you take way before you write a single line of code or even sketch out a diagram. And today, we're diving deep into the art of back-of-the-envelope estimation. So, picture this. You're in a big-time interview. You've got the whiteboard marker, and then they hit you with it. A massive, totally open-ended question like, design Twitter. The pressure is on. So what's your first move? If your gut reaction is to start drawing servers and databases, well, you might be walking right into the most common trap. There's a great story in the book System Design Interview about a guy named Jimmy. See, Jimmy is super smart, super fast, but in system design, being fast without any direction is actually a huge red flag. This isn't about getting the answer first. Jumping to a solution before you even understand the problem is the #1 mistake. So for right now, don't be like Jimmy. And that's really the key here. The right first move isn't about having the perfect answer ready to go. It's about having a method, a way to take this impossibly huge problem and start giving it some actual size and shape. You've got to know if you're building a doghouse or a skyscraper before you even think about laying the foundation. And that method? Well, that's what we call back-of-the-envelope estimation. It's really the art of being good enough on purpose. And look, this isn't about being lazy. It's about being incredibly efficient so you can get a real, directional sense of the system you actually need to build. So what is it really? To put it simply, we're just going to use some simplified math and some reasonable assumptions to get a ballpark figure. We're trading perfect, pinpoint precision for speed and, more importantly, for clarity. The goal here is to just understand the order of magnitude. Are we talking about megabytes or petabytes? A few hundred requests per second or hundreds of thousands? That's the stuff we need to know.
But here's the thing. Even though we're just approximating, it doesn't mean we can be careless. In system design, some of these tiny-looking little numbers and percentages can have massive, real-world consequences.
Just take a look at this availability table. 99.9% availability, that sounds amazing, right? But that's still almost 9 hours of downtime a year. Now, if you can just bump that up to 99.99%, we're talking about 1/100th of a percent better. You've cut that downtime to under an hour. For a major company, that difference is literally worth millions of dollars. These are the small numbers that really matter.
All right, so enough with the theory. Let's get our hands dirty and actually put this into practice. We're going to walk through a great example straight from the book and build our own quick and dirty estimation for a service just like Twitter.
Okay, so here's our challenge. We need to figure out two critical numbers. First is QPS, which is queries per second. That tells us how much traffic our system needs to be able to handle. And second is the storage requirement. That tells us just how much data we're going to need to keep safe.
Now, before we even think about doing any math, this is by far the most important step. You have to state your assumptions. These aren't secrets, they're just reasonable, rounded numbers that build the entire foundation for our estimate. Writing them down like this shows your whole thought process, and trust me, that's exactly what an interviewer is dying to see.
Okay, let's tackle the traffic first. We need to figure out how many write requests, so new tweets, our system has to handle every single second, on average.
Let's just walk through our assumptions. So if we have 300 million monthly users, and we figure about half of them are on the site every day, well, simple math gets us to 150 million daily active users. Easy enough.
All right, next step. If each of those 150 million users posts about 2 tweets a day, that gives us 300 million tweets total. Now, you just divide that by the number of seconds in a day, which is about 86,400, and you land right around 3,500 tweets per second. And just like that, there it is, our average write QPS. But here's the thing. You can't design a system for an average day. You have to design it for the chaos of the World Cup final, for New Year's Eve, or for when some huge news story breaks. So a really common, safe rule of thumb is to just double your average number to get a sense of what that peak load might look like. So, doubling our average gives us a peak QPS of about 7,000. And just like that, we've defined an absolutely critical requirement for our system. We now know our write pipeline has to handle 7,000 requests every single second without even breaking a sweat.
So traffic is one side of the coin. Now let's look at the other, storage. How much physical space are we going to need for all the photos and videos people upload over the next 5 years?
Let's go back to those assumptions. We said we have 300 million tweets a day. If 10% of those have some kind of media, and we guess each file is about a megabyte, well, that means we're storing around 30 terabytes of new media
every single day.
Okay, now prepare for a jaw dropper. You take that 30 terabytes per day, multiply it by 365 days in a year, and then multiply that by 5 years. You get a mind-boggling 55 petabytes. And just so you know, 1 petabyte is 1,000 terabytes. This single calculation immediately shows us the absolutely massive scale of the system we're trying to design.
So that's the whole process in action. To help you actually do this yourself, let's just boil it all down to 4 simple rules you can use as your personal checklist.
First, round your numbers and just approximate. Seriously, make the math easy for yourself. Second, write down your assumptions. You always got to show your work. Third, label your units. Is it kilobytes or megabytes? Ambiguity will kill you here. And finally, practice. This is a skill, just like anything else, and it gets so much easier with repetition. Just try running the numbers on the apps you use every day.
And all of this brings us to what is truly the most important takeaway of all. It's so easy to forget this when you're under pressure, but it's the entire point of doing this exercise in the first place.
Here's what it all comes down to. Your final number might be off. Maybe the real answer is 40 petabytes. Maybe it's 70. Honestly, it doesn't matter. What you've just done is demonstrated a logical, structured way to attack a huge, undefined problem. You've shown how you think. And in system design, that is infinitely more valuable than just getting the right answer.
And that's really the power of this simple technique. It's like a compass that helps you navigate incredible complexity. You have the framework now, so what are you going to estimate first? Instagram? Netflix? The process is exactly the same. Thanks so much for joining me on this explainer.